Okay, Jim, so who are you?
I'm Jim Heilman. I'm with the Massachusetts Institute of Technology. I'm a research engineer there.
Okay, I liked your presentation. Could you maybe elaborate a little bit more on the possible future of biofuels and how it relates to the actual aviation industry?
Yeah, I'd be happy to. I gave a presentation that covered various alternative fuel possibilities for aviation, and there are present quite a few opportunities to create drop-in fuels that could work with today's aircraft. These include fuels such as salicornia, camelina, and even algae. And it's more about developing the feedstock than figuring out how to turn the feedstock into a fuel, because that technology's been certified.
Which do you think will be the leader in biofuel?
Well, that's a tough question. And it has multiple aspects to it. I think a near-term opportunity is camelina. It can grow in the northern plains and be used as a rotation crop. It's not going to be replacing all of jet fuel anytime soon, actually, ever. It's a low-yield crop, but it could provide a solution, perhaps provide fuel to Seattle-Tacoma Airport. Longer term, what we need are feedstocks that can be grown in a sustainable manner, not taking away from food or feed or fresh water. In the longest term, algae seems to hold the best potential, high yields.
Okay, can you elaborate a little bit about algae and why you think this is the long-term solution?
The reason I think algae is a long-term solution, it may not be the only one, but it seems to be a leading candidate today, is because it has a very high growth potential. You can get a lot of algae per acre of land, and you can use a waste product from another industry, which is CO2 from cement, steel, coal, name it. We make a lot of it.
So what do you predict? You said the long term. What are we looking at in regards to getting algae into actual production into aircraft fuel tanks?
Ooh, that's a tough question. I'm not very good at staring into the crystal ball. I don't know. If you talk to somebody who's an optimist, they may say 5 years. If you talk to someone who's a pessimist, they'll say decades. Likely the truth is in between, as it generally is.
So what do you think, what is putting this restraint on our time? Are we in the research area? Are we in the development area? Like, what's kind of holding us back from algae development?
The big thing there is currently the conventional thinking is you would grow the algae and then you have to find a way to dry it. And drying is a cost-intensive, energy-intensive process. But the real interesting research is being done by, of all places, people like Exxon. And they're coming up with methodologies to cause the algae to actually excrete the oil so you don't have to dry it. You'd effectively milk the algae. And this is an R&D process, but if there's a development made, it could be brought to market very quickly. So it's very hard to predict how quickly things like this can happen.
Fair enough. Well, Jim, thank you very much for your time.
Thank you.